Hi, Rogs. Once again, thank you so much for this information. It's just incredible that I can get this kind of help, and I really appreciate it. Okay, so I've got all the information printed out, and I'm going through everything. And I've got this schematic here of yours, and I've read everything, and I just want to go through and confirm what I'm reading, so I understand what's going on. Oh, and by the way, those audio samples were awesome, and yeah, that's really cool about the dithering and everything. Anyway, okay, so what we have is voltage controlled oscillator with a 4046 phase locked loop chip. Adjustable voltage to give us 400K to 1 megahertz clock. The 4017, coming out of these pins divides that by 10. Sorry, I made an error there. The clock signal isn't divided by 10 until it comes out of the 4017 on pin 6 right here. Okay, now that drives my two cascaded 4040s, which is going to run and address the data here. Now, my question for you is, how do I know how many pages the sample takes up in the memory? For instance, how do I know how far the counter needs to count to play the whole sample? Do you know what I mean? And I'm thinking maybe this is something I'd be able to see in the programming software, because you can see what's on the chip. Maybe, I'm not sure. So that's a question. Okay, so it counts, and then it addresses, and then dumps. I have some questions about this part too, but we'll just wait for that. So that's good. Now, the genius of this is it's awesome, because once the most significant bit is reached after the maximum number of address counts, we'll call it, this goes high, which goes high here at the clock inhibit. Now, I would assume it would just go high once, or maybe it stays high because that's how the counting sequence goes. I'll have to look at that. But either it goes high momentarily, which inhibits the clock, or it stays high. Either way, that's good. And then when I hit the trigger again, we have a high here for the master reset on the 4017, as well as the reset here, and away we go. So that's awesome. Okay, now the DAC. Okay, yeah, I fully understand. Your explanation was great. You got to give yourself some credit there. That was really good explanation. I understand. However, I know you have your white noise, and you combine that with the signal. It basically gives the DAC more to bite into. But I don't understand how that white noise is sort of shaped. But don't worry about explaining that. Like, I can look into that. But anyway, I just thought I'd mention that. So, what I'm kind of wondering about is the data latching on the DAC. And does the DAC not have to have some kind of clock signal then? Does it not have to have some kind of a clock signal if it's going to be latching? Because I thought if you feed in, say, 44.1 kilohertz as a clock signal to the counters, then that's going to be the speed out of your flash, which is going to determine the output. But obviously missing something there. But I do get, if you're latching this, then it gives the DAC control over how it's converting, not just reading directly off of the pins of the flash, which I assume is better. So that's good. And, what else? Okay, yeah, and so I would assume it is okay to use like just a regular op amp just to get me like a 2 volts peak to peak or whatever signal for the output. Now, what I didn't look at was the write enable. Write enable? Oh, I don't think that's described in here. But yeah, you need to have the chip enabled, but I'm not writing to anything. I'll have to check the data sheet. But anyways, I am ready to start sort of buying a few of these ICs. A few years ago I went to school for electronics. I did well, but I sort of didn't touch it for a while. Now I'm back on it, and I've got a scope. I'm going down to get a scope on Friday, a function generator, etc. So I'm going to be able to start building something akin to this, and I'm excited to do that. So anyways, once again, thank you so much for your help, and if I have any other questions, I'm sure I will have more questions. I will post them. Take her easy. Bye.